What's going on? My name is Zach Holcomb with Additive America. Welcome back to Tool of the Week. This is episode 3. I've got my good friend Richard Savage with Savage Automation here again. And Richard, what is this week's Tool of the Week? What do you have for us today?
All right, this one's a fun one. We're going to branch out from injection molding and go over to a packaging application. So this is a packaging machine. So before I show you the end of arm, I'm going to set up your scenario for you. So we've got this tray of 986 vials. And these vials are used for COVID test, flu test, strep test, all of these different things. And we have to take these vials out of this giant tray and put them into boxes of 25. And we're faced with kind of a fun challenge here. And when I say fun, it wasn't very fun. They're spaced in the tray at 1/2 inch. But into the final box, they're at 3/8, which for those of you following along at home, that's an 1/8 inch difference for each different part. They don't make a cylinder that just moves an 1/8 inch, at least not that I've seen. So we had to come up with a way that we were going to compress these parts. We got to pick up 5 of them and then push them together and put them in the box.
Okay.
So what we came up with looks kind of like this. So the yellow and teal parts are all 3D printed. And then we have this little aluminum off-the-shelf cylinder here. What we did is we made each of these parts have its own suction cup, and the spacing between each of these is an 1/8 inch, right? That's the spacing we need for our box. Mm-hmm. So what it does is it pulls this cylinder in. When the cylinder pulls in, all of these compress down, taking an 1/8 inch out from in between each one of them. That way we can pick up these vials, then it lifts back up and we release this cylinder. And in between each of these, you can see we've got a little rod here that they're all riding on. We've got a spring. So when you release that air pressure, all those springs, they come out and they equalize in between each of those. They all spring back, pushing the same force between all of those. And they spread them all back to equal spacing. This would be a really tough design to do any other way without additive. Just from a design standpoint, thinking about how we're going to machine it, how it's going to work, through to a testing standpoint, machining all of these parts and testing out to see if it is going to work, be a lot of money and a lot of time versus just printing it. Each one of these, we've got an internal channel. So we've got the vacuum line, the internal channel comes up. You can see inside of here, just a little tiny bitty internal channel that comes out to the front so that we can plug in our air lines here.
Gotcha. Very cool. This is the one that you had. Is this the one? Was this at AMUG?
Yeah, so we actually submitted this one without the aluminum cylinder at AMUG. We submitted it for the technical competition, and we 3D printed the cylinder on there. And it worked out really cool as a concept, but in a production environment, we didn't want to find out how long that lasted at the customer's expense. Right.
We'll have to get one and set it up on like a little machine and then just run it and see how long it lasts.
Yeah, we've been that's one of the ones we bring around to the trade show with us all the time. So it's been cycled a lot of times. I haven't kept count, nice. But it's definitely possible, and it can help reduce weight in a situation like this where when you look at that cylinder is the heaviest thing on there.
Gotcha. Yeah, very, very lightweight, small unit, and it's almost like you're giving the almost like the acuity of like having fingers on the end of arm tool there. Like it's grabbing, it's adapting, it's placing. It's very neat that you're able to drive basically the difference in the spacing that you need from pooling the parts to packaging the parts and then implement that all into one tool, one design. I mean, I don't know about how they would do this in any other setup, but I mean, like you don't want to double handle the parts, if you know what I'm saying.
Exactly. And this is a speed critical situation. So we're actually unloading 5 of these parts. We run them past a vision system to check that none of these glass vials is broken. And then we place them in the box in less than 2 seconds. So each of those cycles of picking up 5, checking, placing them in the box, that takes less than 2 seconds. Any additional weight on this is going to slow us down and make us less effective.
Gotcha. Yeah. So yeah, I guess my question on that would be like, what is the injection time almost as fast as your pick and place time?
Well, so these are actually manufactured before we get them in the tray,
Oh, I gotcha.
right? So we
So
get a
more of an
full tray
inspection.
of these parts. Yeah. The problem is they want to be better than a human, and we've got some harsh competition here. These people who do this are incredible. You know, they're looking at these vials so quickly and packaging stuff up, and so in order to be economically viable, we've got to be faster and better.
Mhm.
I can tell you that we are. We are faster and better.
For sure, for sure. And so what's the setup there on, are you showing to an optical, like is it for shooting transparency or like what is that
Yeah,
kind
so
of
we
like?
actually have two different cameras, high-speed cameras that are looking at this. So the
Okay.
vial, what it is, it's a glass vial with a little plastic cap on it. And in the bottom of this vial, there's what's called a reagent. It's basically the chemical that tells you whether you have whatever sickness they're looking for or not.
Okay.
And that reagent's got to be there and it's got to be a certain way. And so we've got a camera looking just at that. It's this little white powder. It's just looking at that to make sure they've got enough in there and that it's going to work for the clinician when they go to do this. The other thing is you got all these glass vials, right? It's a manufacturing environment. You're going to get some that get cracked, broken, the lids aren't on them. And so that second camera is just looking for that. It's looking to make sure there's no cracks, no damaged vials. And if there is, we actually drop them off on our way back to get more vials. So we don't actually take any more time if we reject parts. We go right back to get some more vials and drop those ones off.
Wow. Wow. That's really cool. I mean, the human can't even do that, if you know what I'm saying. I mean, they got
Exactly.
to think, adjust, replay. Yeah. Very cool.
Exactly.
Because they're constantly reprogramming themselves. Very neat.
That's how
Okay.
we ended up winning. But that's also why you'll see we have separate vacuum channels in this. Normally, we really like manifolded vacuum channels. In this one,
Mm-hmm.
where you need individual control, we've got a separate channel for each one of these.
Gotcha. Very cool. And a little different than the one we had, I think in week one, where you're not jumping down in the mold. So the overall dimensions or width of that, the profile, having those extra tubes coming out and not being manifold probably doesn't really hurt you in this scenario.
Exactly.
Okay.
Exactly. It doesn't really hurt us there. We've kind of got an open space to work with. But you do mention profile again, and in any automation system, that really is critical. You know, we actually fit in between these two cameras. Our space that we end up going through is about that big
Wow.
because we've got all this equipment that has to be focused and on this part. We've got lighting for these cameras that has to be shining in the right spot on the parts. Profile really is a big deal. And so again, being able to do complex profiles, do these, we've got this cool window that this part goes into. This would have to
Mm-hmm.
be two parts if we machined it, right? Because we've got this little undercut here. That's going to
Yeah.
be difficult to machine in a single body. Because we're printing it, we got this nice single body. We just slide our cylinder in there, and it really can't come back out once it's in there. Once it's bolted in,
Mm-hmm.
even if your screws come loose, it's got nowhere to go.
Yeah, it's effectively trapped in the geometry there. That's very cool. Yep, value added again there from the additive process on that part in particular. In addition to the weight, the machinability, the unmachinability of those characteristics and the geometry really, really lend themselves to the strengths of an additive process. So very cool.
Right.
Very cool. Well, right on, man. Anything else you want to add on that one there?
No, I think that one speaks for itself. It's one of the coolest ones we've done. We're pretty pleased with it.
Mm-hmm. Very cool. Very cool. I think we've got some photos of those, so they'll probably be sprinkled throughout the video. But yeah, it's very cool. This is one where you probably got one of the first ones where you definitely got to see us show it on the screen, but also some pictures of the end use part, kind of the way that it was built. So I hope you enjoyed that one. Again, this was week 3 or episode 3 of Tool of the Week. Richard Savage of Savage Automation. You can reach out to him at savageam.com. You can also hit him up on the LinkedIn. I'm Zach Holcomb with Additive America. You can get me on the LinkedIn as well, or also at additiveamerica.com. If you have parts like this and you're just looking for a place to print them, hit me up. If you have some places where maybe you could use some automation in your business, or where you work to pick in place or pull parts from molds or anything like that, inspection, things of that nature, definitely reach out to Richard. Appreciate it. We'll catch up with you next week on week 4, episode 4 of Tool of the Week. Thank you.